Okay, so the cardiac cycle only applies to pure students and IP students of biology. So what we'll be looking at today is when you hear the sound under the stethoscope of the heart beating, right? Okay, so what over here, we'll be looking at the right side of the heart itself. Okay, so can you all edit this? Is the right side of the heart, okay, and the right ventricle, okay, because we're talking about the deoxygenated blood. Okay, so let's do a little bit of recall. So you have got deoxygenated blood that flows into the superior and inferior vena cava, which will then enter into your right atrium and then into your right ventricle, right? And then from the right ventricle, there will be ventricular contraction. So when the ventricles contract, the deoxygenated blood will enter into the capillaries surrounding the lungs, the alveoli, via the pulmonary artery. Okay, so at each junction, so from your right atrium to your right ventricle, it is separated by the tricuspid valve. Okay, so over here, when blood enters the right atrium, there will be an increase in pressure. Okay, so when you follow my cursor, you will see that there is an increase in pressure over at the dotted line of the atrium here. Okay, so increase in pressure, tricuspid valve opens, so blood will enter into the right ventricle. Okay, now at the last junction, when the right atrium has only a little bit of blood left, what happens is that it has to force all the remaining blood into the right ventricle. So there will be atrium contraction. Okay, so when the atrium contracts, there will be a drop in the pressure of the atrium. Follow? Okay, so anything that has to do with a contraction, we call it is systole. So atrium means the atrium, systole means contraction. Okay, so blood falls into the relaxed ventricle. Okay, then after the atrium will relax after the contraction, and relaxation we call it diastole. Okay, so now the blood is all in the right ventricle itself, right? So when blood enters all into the right ventricle, the tricuspid valve will close. Okay, so why does it close? Because right now the pressure of the right atrium is lesser than the pressure of the right ventricle. So it doesn't make sense for the tricuspid valve to be open. Okay. However, what will open now is that since the right ventricle has higher pressure than the pulmonary artery, you will have opening of your mitral valves, okay, which connects the right ventricle along with the pulmonary artery. Okay. Another purpose of the bicuspid valve closing is also to prevent the backflow during the contraction of the ventricles. Okay, so imagine if, let's say, this is my atrium, this is my ventricle. So when the ventricles contract, it can possibly backflow, which you do not want. Okay, which is why the tricuspid valve will close. Now, so slowly as the blood is in the right ventricle, following my cursor, okay, the right ventricle pressure will slowly start to increase as it contracts. Okay, so when it gains enough contraction power, okay, what happens is that there will be a final complete full contraction, which will cause the ventricular systole. Okay, so ventricular systole over here, the moment it contracts, you will have the maximum pressure of the ventricles. Okay, so ventricles contract, thereafter the ventricles will pump the blood into the pulmonary artery. So when it pumps the blood into the pulmonary artery, I'm sorry, this one is the semilunar valve. Okay, so when it pumps the blood into the pulmonary artery, the semilunar valve is open, so blood gush through the semilunar valve into the pulmonary artery. Okay, so right after the blood of the ventricles is being pumped out, the ventricles walls will start to relax, resulting in a decrease in ventricular pressure. Follow? Okay, so looking at the notes here, what happens is that here your ventricles will begin to contract. Okay, this one is supposed to be tricuspid valve. Okay, closest to prevent the backflow. Okay, so since right now the pressure in the ventricle will be higher, what happens is that the pressure will cause the opening of the semilunar valve, which ultimately causes the contraction of the ventricles. Okay, so when ventricles relax, that is your ventricular diastole. Okay, now of course your heart is such that you will have the 4 segments. Okay, blood doesn't enter from one side and then after that leave and come back from the other side. Okay, it does not happen that way, because at no point in time are your heart chambers empty. Okay, so what is actually happening is that blood is flowing, deoxygenated blood is flowing here, reoxygenated blood is flowing here. Okay, so simultaneously the tricuspid valve and the bicuspid valve will open. Okay, and simultaneously blood will enter from both the atrium into its respective ventricles. Okay, so again at the same time both the atria will contract to force the last bit of blood into the ventricles. Okay, so once it does and my tricuspid and bicuspid valves closes, okay, that will produce the first sound, which is your loud sound. Okay, so this one, tricuspid, I got 3 valves, bicuspid, I got 2 valves, so total I have got 5 valves, right? Okay, so after that my ventricles will contract, both will contract. One will be to my pulmonary artery and the other one will go to my pulmonary veins. Okay, so this is via your semilunar valves. Okay, so how many semilunar valves do we have? 2 of each, so which means total I have got 4 valves. Okay, so when the valves closes, that will produce the softer dub sound. Right, now the first one, which we call the lub, is louder than the dub, simply because I have got 5 and I have got 4. Okay, so once that happens, one lub and one dub is considered to be 1 cycle. Okay, so from there the next cardiac cycle will now repeat itself again. Okay, so when we look at, let's say when you're going for your blood pressure testing at the clinic, you realize that they have got this thing that is called your blood pressure reading, right? So the top number is always the larger number, which is the systole number, and the bottom number is the diastole number. Okay, so now you understand that the systole is measuring the contraction, okay, whereas the diastole is measuring the relaxation. Okay, so go through the graph again. Okay, remember or imagine how the heart flow or the blood flow is going through the heart itself before attempting to understand all the words. Okay, it will be easier to understand the cardiac cycle when you look at the heart as a full picture instead of analyzing it in words and diagrams itself. Okay, so try out some of the questions, and if you're not sure, we can go through it. Thank you.